How's everybody doing out there? Well, I hope everybody did a good job working with their testing for goodness of fit. So for the next section, this is kind of a multivariable chi-squared test that we're going to actually be doing, because now instead of having just one row of data or one column of data, now we're going to have rows and columns of data that are kind of working together. So if we look, this whole section, we're going to be working with things called contingency tables, which is more or less kind of like a matrix in this case. And so for the one that's given in our little example here, we've got how many hours students studied per week based on what their major was. And so what you can do is read up and down and across. So for example, in the 0 to 10 category, humanities, 68 humanities majors studied 0 to 10 hours per week. 106 social science majors spent 0 to 10 hours studying. Business 131, engineering 40, and then 11 to 20 we had 119 for humanities, 103 for social sciences, 127 for business, 81 for engineering, and then more than 20, 70 for humanities, 52 for social science, 51 for business, and finally 52 for engineering. So again, we're not going to do anything with this example, but I do want to kind of set up what the observed and the expected is going to look like, just so we can get an idea and get this thinking, so when we get to our examples, we'll know what to do. So if we were given a set of data that looked like this would be considered our observed matrix in this case. And so what we'd want to do is go through and total everything, rows, columns, all that thing the whole way across. So I'm going to add like a little section down below here. It's going to represent our total. And then I'm going to add a little total column out here as well. And so the first thing we're going to do with our observed matrix is go ahead and add up all these rows, add up all these columns. And so if I add up this first row, I'm going to get 257, 261, 309, 173. And then if I add them across, I'm going to get 345, 430, 225, and then a total of 1,000. So it looks like we actually surveyed 1,000 people total in this situation. All right, so the tricky part about this is we need to come up with our expected value matrix that's going to be the same size as the matrix that we have, and where we actually come up with these values are going to come from this little formula that we have here. So what we're going to do is take the row total times the column total divided by the grand total. And then the problem is we have to do that for each and every single row and column that's in our table. So like in this case, we've got 12 items total that are in our table. So we'd have to do this step 12 times to get it finished. So if we look, I did a little example for the humanities in the 0 to 10. So notice our row total was the 345, our column total was the 257, and then our total was the 1,000. So if I multiply the 345 by the 257 divided by 1,000, then I see in my very first column, I'm going to get 88.665, or if you want to round it to 88.67. And so then what we'd have to do is we'd have to do that same exact thing for the social sciences. So we'd multiply 345 times our 261 divided by 1,000, and that's going to give us the social sciences second position. And then same thing for business, same thing for engineering. So unfortunately, there's no nice, easy shortcut to do this other than kind of just brute force go through it and do it on your own. And so what it's going to look like, and so I'll write the answers up here so you can see, but you should go through and check on your own to verify you're getting the exact same numbers as what I have written down. So I'm trying to find a place to put it here where you can actually see it. Let's see, because I don't have much room. So let's see if I can squeeze it into this spot. All right, so that 88.67 that I talked about would be equivalent to going in that spot there. So I didn't list all the stuff, but this was humanities, social sciences, business, engineering. And then this would be our 0 to 10, 11 to 20, and then greater than 20. So again, I'm just going to jot down what these should be, but I would recommend you try them on your own. Make sure you're getting the same numbers, and if you're not, let me know so we can talk about them. Oops. 110.51, 112.23, 32.87, 74.39, 15.75, 88.73, and 38.925. All right. So I'm going to stop the video here and give you a chance to go and see if you can come up with the same expected matrix that I have for this given set of data that we have. And then when we come back, then we'll talk a little bit more about next steps and where to go from here. So try to figure out that expected table. If you can't figure it out, message me and let me know. Otherwise, I'll see you in the next video.